Hi everyone. For today's topic, we will be talking about importance of points of reference and coordinate system. So these are the key points of our topic, and in my part, I'll be discussing the surveying and points of reference. And the remaining key points will be discussed by my group mates, which you can see as you slide through this presentation. Let's have a brief review about what is property surveys and its roles in different sectors. So, property surveys are measurements and assessments used to define land boundaries, identify features, and determine legal property lines. Now, talking about its roles in different sectors, in real estate, it ensures accurate property boundaries for buying, selling, and disputes. In construction, it guides building placement and prevents encroachments. And in land management, it helps with the zoning, land use planning, and resource allocation. So these are the types of property surveys. First, we have boundary surveys. It determines exact property lines and resolve disputes. Second is topographic surveys. It uses map elevation and land features for construction and planning. Now, in construction surveys, it guides engineers in placing buildings and infrastructures accurately, while in cadastral surveys, legally define land ownership, subdivisions and governments, and land records. Now, let's talk about point of reference. So, point of reference are fixed locations or markers used to determine positions, measurements, or directions in surveying, navigation, and mapping. They serve as known coordinates or physical landmarks that help establish boundaries, align structures, or guide spatial analysis. Point of reference has four types. These are natural points, man made points, geodetic control points, and benchmarks. Natural points are permanent landmarks like mountains, rivers, or coastlines. Man made points are roads, buildings, or survey monuments used as reference. For geodetic control points, these are precisely measured points with known coordinates used in large scale mapping and GPS based surveys. And lastly, for benchmarks, it is a fixed elevation points used in leveling and height determination. So, surveyors and geodetic engineers rely on these reference points for accurate land division, construction planning, and geographic data collection. So, for the selection and establishment of points of reference in the field, surveyors and geodetic engineers choose points of reference based on specific factors to ensure accuracy and reliability. So, first in line for the criteria is the accuracy, which means that the location must be precisely measurable using instruments like GPS, total stations, and other leveling equipments. Second, we have stability. So the point must be fixed and unlikely to move over time. Like, for example, a bedrock. A bedrock is a permanent structure. And then third, we have visibility. So it should be easy to identify and access for future surveys. And fourth, we have elevation and terrain, which means points should be placed in stable areas, avoiding locations prone to erosions, flooding, or interference. So choosing and setting up points of reference in the field means picking stable and easy to see spots that won't move over time.
Good day, everyone. I'm Katleya Angkay and I will discuss the coordinate systems in surveying and methods of establishing control points. There are three common types of coordinate systems. First is Cartesian coordinates. Use x, y, and z values to define positions in a straight line grid. Geographic coordinates use latitude and longitude to locate points on the Earth's surface. Polar coordinates define a point based on a reference direction and distance. Now let's discuss local and global coordinate systems. Local coordinate systems is specific to a project and are often based on an assumed reference points. These commonly used in construction and small scale surveys, while global coordinate systems such as UTM and WGS 84 provide standardized positioning worldwide. So, why do we use different systems? So, local systems simplify small projects by using a custom reference, while global systems ensures consistency across different locations, which is crucial for large-scale mapping and navigation. Now let's move on to methods of establishing control points. There are three main methods. First is global positioning system. Uses satellites to determine precise locations, making it one of the most accurate methods. Triangulation determines a point's position by measuring angles from known points. Last is trigonometric leveling. Measures elevation differences using angles and distances, which is useful for determining heights. So why is geodetic control important? For large-scale projects like national mapping, geodetic control ensures accuracy over large areas. For specific surveys such as constructions and property boundaries, control points help maintain precision within a smaller area. Some of the tools used in establishing control points include GPS receivers, total station, and digital labels. These instruments ensures accuracy in surveying work. And that's all. Thank you.
Control points and coordinate systems are fundamental in various fields, including property boundary determination, construction layout, and infrastructure development. By providing precise reference points, these systems ensure accuracy and consistency in mapping, designing, and implementing projects. My topic explores their applications and the challenges encountered in establishing control. Control points define the legal limits of properties, ensuring accurate measurement and clear ownership. They enable accurate mapping of property lines, reducing disputes and legal complications. So control points and coordinate systems are very important in land surveying as it helps to clearly define legal ownership and prevent disputes by ensuring nga tanang control points kay naka-establish to their exact placements para makabalo ang owners kung asa rataman ang ilang yuta. So surveyors use GPS and total station to establish precisely the boundary markers. Second, control points serves as the foundation for construction layout, providing reference points for the precise placement of structures, roads, and other infrastructure. In construction project, control points are used by the engineers as it serves as the reference markers for laying out structures. This is the basis to the position of foundation, walls, roads, and utility networks. Without these control points, even minor miscalculations can result in significant structural misalignment. Before constructing a high-rise building, engineers place control points on site to ensure the foundation and floors are aligned precisely, preventing structural misalignment. Coordinate systems guide the construction of roads, bridges, and tunnels, ensuring proper alignment, slope, and elevation for efficient and safe infrastructure. Infrastructure development also benefits greatly from coordinate systems. Proper alignment, slope, and elevation are crucial when constructing roads, bridges, and tunnels. These systems help engineers maintain seamless connectivity and structural integrity, ensuring safety and efficiency. When constructing a highway, engineers use coordinate systems to maintain a consistent slope and curvature, ensuring a smooth driving experience. Control points also help locate and map underground utilities, such as water and sewer lines, preventing damage and ensuring accurate installation. So before digging for a new sewage system, workers use coordinate systems to map existing underground pipelines to avoid breaking water supply lines. Beyond construction, control points play a vital role in real-world applications such as in urban planning, civil engineering, and real estate. Urban planning utilizes control points for mapping and managing city infrastructure, including road networks, buildings, and public spaces. For example, city expands its transportation network by planning a new metro system, Control points help align metro stations with existing roadways and public spaces. Second, in civil engineering projects, it relies on control points for site surveys, foundation design, and construction layout, ensuring accurate and safe infrastructure development. For example, in creating a dam, it requires precise geodetic control points to manage the flow of the water and to ensure a long-term stability. Developers and real estate professionals use coordinate systems to assess land parcels for investment and development. Accurate surveys ensure compliance with zoning laws and enable efficient land subdivision. If a real estate developer plans to divide a large piece of land into multiple housing lots, accurate surveys ensure that each lot complies with legal zoning regulations. Establishing accurate and reliable control points is crucial for serving, construction, and infrastructure development. However, several challenges can impact the accuracy and effectiveness of these control points. These challenges include environmental factors, second is errors in measurement and the terrain and accessibility issues. First is the environmental factors. Surveying in extreme weather conditions, dense vegetation, or remote areas poses difficulties in establishing and maintaining control points as it affects GPS signals and instrument accuracy. So surveying land in a dense rainforest can be challenging because trees block GPS signals, making it harder to get precise measurements. Second is errors in measurement. Human errors, instrument calibration issues, and signal interference can lead to inaccuracies in control point positioning. For example, if misreads sa surveyor ang instrument or records incorrect coordinates, so the entire project layout can be compromised, leading to costly corrections. Third is terrain and accessibility issues. Mountainous regions, water bodies, and unstable ground conditions complicate control point establishment. Advanced technologies such as drone mapping and LiDAR help overcome these challenges by capturing detailed topographic data. For example, if a surveyor is working in hilly areas, struggle to set stable control points because shifting soil and landslides can move the marker over time. To ensure the reliability of control points and coordinate systems, surveyors use these methods. First, they use high precision instruments, such as modern GPS receivers, total stations, and laser scanners enhance accuracy. Second, regular updates and adjustments. Periodic recalibration of control points accounts for land shifts, erosion, and infrastructure changes. So after an earthquake, engineers reassess control points to ensure that buildings and roads remain properly aligned. Third is redundant measurements. So multiple readings from different angles and instruments help cross-verify data. So surveyors must measure a site from various control points and cross-check data to ensure that no errors before proceeding with construction.
Hello, everyone. Today, we are going to talk about the importance of accuracy and precision in surveying. Surveying is not just about taking measurements, it plays a critical role in determining property boundaries, guiding construction projects, and preventing legal disputes. Even the smallest errors can lead to big problems, including financial losses, unsafe buildings, and lawsuits. To fully understand this, let's first explore the meaning of accuracy and precision in surveying. Accuracy means measuring something as close to its true value as possible, while precision means getting the same result consistently. In surveying, both are essential. Imagine measuring a property boundary. If the measurement isn't accurate, someone might lose or gain land unfairly. If it's not precise, we might get different results each time we measure, leading to inconsistencies. Mistakes in reference points, which serve as a starting location for surveys, can result in incorrect maps, property line conflicts, and misaligned buildings. Now let's discuss how such errors can lead to legal problems. One of the most common legal issues caused by surveying mistakes is property line disputes. When surveys are incorrect, Neighbors may claim the same piece of land, leading to costly lawsuits. In some cases, incorrect measurements have led to entire buildings being placed on the wrong property. This can result in expensive demolitions, lengthy court battles, and compensation claims. Surveyors must ensure their data is accurate to prevent such problems. Speaking of construction, let's look at how errors in surveying can impact large engineering projects. Surveying is a critical part of construction. Engineers use survey data to plan the foundations of buildings, roads, and bridges. If measurements are incorrect, buildings may not fit properly on their foundations, roads may not align, or bridges may not connect correctly. A real-world example is a bridge project where two sections were built separately but didn't align when they were supposed to meet in the middle. This mistake cost millions to fix and delayed the project by years. Let's now explore a high-profile case study where survey errors had a long-term impact on a major One of the building. Most well-known examples of surveying errors affecting construction is the Millennium Tower in San Francisco. Engineers failed to properly analyze the soil and foundation conditions, causing the buildings to sink over time. The weight of the structure was not evenly distributed, and now the building tilts. Lawsuits have been filed, and repairs are expected to cost hundreds of millions of dollars. This case shows why precise and accurate data is essential before starting a major project. Now, let's compare this to a case where accuracy and precision led to a highly successful engineering project, the expansion of Panama. Unlike the Millennium Tower, the expansion of the Panama Canal is an example of successful surveying. Engineers had to ensure that the new locks aligned perfectly with the existing canal system. Using GPS, laser scanning, and 3D modeling, surveyors were able to provide highly accurate measurements, ensuring that ships could pass through smoothly. This project highlights how modern surveying tools contribute to accuracy and efficiency. So, how can surveyors continue to improve accuracy and precision? Let's look at some of the best. To improve accuracy in surveying, professionals use advanced tools like GPS, drones, and laser scanning. These technologies help minimize human errors and provide highly precise measurements. It's also important to regularly check and update control points to ensure they remain stable over time. Another key practice is comparing new survey data with past records to detect and correct discrepancies early. By using advanced tools and best practices, surveyors can continue to provide reliable data for land development and engineering projects. That's all for my part. Thank you.
Good day, everyone. My name is Hannah Isabel Sandoval, and I will be discussing the modern technology in surveying. So, as we can notice, it is very evident nga mas dali na lang mag-conduct og survey nowadays. It is faster, more accurate, and more efficient than ever before. And that is because of modern technologies. One of the biggest game changers is drones. So, sa una no kay the geodetic engineers or katong mga surveyors would have to physically collect data on the ground, which is of course very time consuming nga maabtan pag pila ka adlaw or semana or kanang mga bulan ba kaha if kanang dako na gyud ang area nga kailangan surveyhon. But now, with the power of drones, the geodetic engineers can fly them over the target area and capture high resolution images in a matter of minutes. So this is very useful, especially if dako ang area nga need surveyhon or kana mga remote areas bitaw. Kay ug gamitan mo gud nato ni siya og mga traditional techniques or katong mga traditional methods kay time consuming na siya and mahal. Kay imagine pila mo kaadlaw mag-conduct og survey, 'di ba? So, of course, drones also provides an efficient way to capture images from different angles, which can improve the overall quality and accuracy of data. The next one is we have LiDAR or the light detection and ranging. So this uses laser beams to scan the ground and create detailed 3D maps. It is so precise that it can even detect slight changes in terrain. So mo ni naka-perfect siya gamiton no for flood mapping, construction, and even environmental studies. So the third one is we have satellite-based positioning systems like the GNSS or the Global Navigation Satellite System. These provide real-time, highly accurate location data, which makes it easier to set control points without needing long, complicated fieldwork. And lastly, ang katong mga data nga na-collect nato from drones, LiDAR, and GNSS is brought together and analyzed through Geographic Information Systems or GIS. So the GIS helps surveyors or genetic engineers analyze and visualize information, which allows them for better decision making and planning. So, whether it is for urban development, land management, or disaster response, technology is making surveying smarter, faster, and more reliable. So, to sum up our report, precision in surveying is not just about measurements, it is about ensuring consistency, protecting property ownership, and enabling efficient land development. And as future geodetic engineers, we must always strive for accuracy in our reference points and coordinate systems. This has been Group 4. Thank you for listening.